So this is just will starting now. So as and when some people start, we'll add accordingly. So this is like a basics on this AUTOSAR diagnostics I'm giving. Okay. So as you are aware that I'm starting this AUTOSAR course. So this is just a demo session, just to give you idea like how I teach and do you think am I capable enough to give the training? So it should not happen like you pay money now and later you regret that yes you have invested deadly, or the person who is teaching is not capable enough to teach. So that's why and everyone aware is that like diagnostics and this memory stacks and all those things are you can see the materials available, okay, everywhere. But if interviewer ask you question, you will not get any answers, like, because by reading the things or by watching the courses what are available right now, some pre-recorded courses and all those things are there, okay. With that you will not get anything. So if you are saying someone that yes you know the AUTOSAR, because you cannot switch to AUTOSAR directly without having hands-on, but you will not get hands-on also without having the AUTOSAR project or something like that. So it's like asking fresher that do you have experience of 5 years. So fresher experienced people is always fresher at some point of time. So it's like that only. So AUTOSAR you will not get hands-on anywhere, but you have to pretend that you know AUTOSAR. And to interviewer, if you say that I know the AUTOSAR, you will always tell that no, like you have done this course, that course, something like that. But interviewer's mind says it different, because he interviewing you, so he feels that you already worked on this AUTOSAR. So we always fail to answer some of the questions. So in this meeting, I will also guiding you regarding that also, like some mock interviews and all those things also I'll show you. Okay. So I'll just switch to slide. So about me, already everything is on LinkedIn only. Like I have 11 plus years of experience, and I have worked on AUTOSAR more than 8 years, and then complete embedded C. I have worked on all the BSW stack configuration, all the models which are already available on the AUTOSAR side, and also MCAL integration. I have experience in MCAL integration also. So all the MCAL models like ADC, GPT, Watchdog, everything, whatever presents in the MCAL, so that I already have experience of. Apart from that, diagnostics, then XCP for calibration, then NvM. I have actually very good understanding on the NvM model. More than 3 years I have worked on the NvM only, and I contribute more on the NvM side. So whatever stuff related to memory like NVMP, FLS, all the models I already done the integration of. Okay. So just go through the basics of AUTOSAR, mostly all aware, but I'll just give you the brief. So in the AUTOSAR we have application layer, then RT, service layer, ECU abstraction, MCAL, and microcontroller. Application layer, like it's a software components actually. It's in normal C language you can consider it as our C functions or maybe C files. Like that way in our normal non-AUTOSAR things we have ADC.C or maybe some ECU.C or a body control model. So let's say BCM.C. So we have different .c files for doing certain operations. Similarly, in the application layer, it is like that files only. Like, so we have some diagnostics component. So we have some diagnostics app.c, or we have some NVM component at below layer. So we'll be having some NVM app.c. So whatever things related to app will comes under the application layer. Then we have RT. RT is nothing but it's a middleware, okay, or maybe it's a mediator, or you can consider it as a bridge between upper layer and the below layer. So just because of AUTOSAR only, application team can work separately and below team work separately. So it becomes the mediator to have a communication between the above layer and below layers. So it is like that only. Then we have the service layer. In the service layer, what is the service that we provide? Let's say we provide some memory storage capacity like NvM. We provide some diagnostics related services. We also provide some diagnostics events related services. So whatever things are related to services will comes into the service layer, like memory. Then in terms of memory we have NvM. In terms of diagnostics we have DCM DEM. In terms of operating system we have OS module. So all comes in the service layer. Then we have a issue abstraction layer. Issue abstraction layer means mostly all the interfaces like a CAN interface, Ethernet interface. Then in terms of memory, we have MEMIF interface. So all the interface are into the ECU abstraction layer. Then we have a microcontroller abstraction layer. Microcontroller abstraction layer means actual peripherals. So like we have a trans receiver or CAN driver. We have this fee module. So fee module also a part of MCAL. So whatever things related to the controller level. So that comes under this microcontroller abstraction layer. We have a GPT like a general purpose timer. We have watchdog manager. Not sorry, watchdog manager, watchdog driver. Watchdog manager comes under the service layer only, but the uh, watchdog. So this comes under the yeah, this one microcontroller abstraction layer. And then we have actual microcontroller. It can be ST microcontroller, it can be Renesas microcontroller, or Infineon microcontroller, whatever we have, that it comes under. Then we'll just move to next. So this is about the AUTOSAR Diagnostics basics. So generally I'm focusing on this AUTOSAR Diagnostics only because mostly interviewer asks questions on this only. So we have offboard and onboard concept. So onboard means whatever things happening on the controller side. Offboard means outside the controller. So something happens, let's say your car is showing some errors or something like that, then we always go to the technician. So technician will have one diagnostics tool, we term it as a OBD tool or whatever maybe. So he just connect that OBD port to our controller and he requests the services, and based on that they get some response. So it is like that only, like a request and response concept. So diagnostics is nothing but something happened to your controller, and based on that you want to know what exactly happened. So we will send request, and based on that we will get some responses. So it is like offboard and onboard. So so now we'll be more focusing on onboard, means whatever things are happening inside the controller when diagnostics tools can be anything, like we have a CANoe, we have a CANalyzer, we have CANape. So many tools are there. Some other tools also we have available, so to send the request. Some OBD tools also. So that it is these are the tools via which we can get the things. So we'll dive deep into this one, AUTOSAR Diagnostics, onboard AUTOSAR Diagnostics. So if you see generalized behavior, how the modules are, and what things are there in the AUTOSAR Diagnostics. So I'm just giving you overview, okay? It's not like a detailed session. Like, I'm just showing you how I explain the things, okay? So in the AUTOSAR Diagnostics basic, it's like a similarly layered architecture only. So in the application, we can write any of our application, like let's say it is related to standard diagnostics, or it is related to cyber security, or it is related to some NvM app. So because with the any of the app, we can access the diagnostics actually, because diagnostics means error can happen at any application. So every application has access of diagnostics modules. So we'll see this one RT, then DCM. In the DCM also interacts with the PIM. PIM means function inhibition manager. Okay, so if something wrong happens, which all functionality you have to inhibit or disable, so that also DCM interacts with them. Then we have a DEM. DEM means Diagnostics Event Manager. It is used to trigger the event if something happens. Let's say some voltage is low, then it will trigger this diagnostics event, like over voltage, or maybe voltage is less than less voltage or under voltage. Some all the events it will trigger, and with the DCM we can able to read the what all events happen inside the controller, what wrong happens inside the controller. So that thing also we can do. Then it also communicates with the DLT. DLT means diagnostics log and trace. So there might be chance that something bad happens in the controller. So that logs it will be stored in the DLT, and then based on request via diagnostics request we can access those as well. Then DET means diagnostics error trace. So diagnostics error trace means some errors are coming which are unintended. So what all errors are there, that errors we can it is reported in the DET, but these things we can access via DCM, like Diagnostics Communication Manager. Then flow will be like some, let's say application has some data and that we want to route. Then it goes to RT, then DCM, then from DCM we have a PDR means like it's a router only, PDU router. So we have a fixed diagnostics request and diagnostics response PDU that we have to route based on the things, like if our data is, let's say, less than 8 bytes or equal to 8 byte, then it will directly route to the PDR and then bus interface. Bus interface means either it can be CAN, Ethernet, or even FlexRay also. And then bus TP means like a CAN TP, FlexRay TP, or Ethernet TP. So if the data is more than 8 byte, then it will route to the bus TP actually. And then similarly, CANIF means CANIF or Ethernet if or FlexRay, and then relevant trans receivers like Ethernet trans receiver or FlexRay trans receiver or the CAN trans receiver. And then at the end it goes to the pins, relevant pins, and then from microcontroller it will go to the physical world. This is just the basic flow how it looks like. So we'll just see anyone try to add or join or not. Yeah, some people are waiting in the queue, so I have added them. Anyway, this session I am recording, so even if you join late, no trouble. We can have this recorded things. Okay. Thanks all for joining and taking out Saturday time. So this is the structure, okay, where our DCM resides. So in the whole things. So actually DCM, as I mentioned, DCM is a service. It's a part of service layer actually, and it comes under the communication services. So if you maximize it, it will be having all those things what I mentioned earlier, like generic CANM, DCM. Then we have AUTOSAR COM. So these are the basic things we will need. Obviously, communication stack consists of all those things, and these are the relevant modules also which we will require to have a communication. Let's say if you want to send request, it should not be like a DCM only taking care of. It has to go to all the layers, like a COM layer, COM IPD layer. Then we have trans receivers. Then we have to also check whether CAN is available or maybe FlexRay is available, because we have to see the state of the communication also. It should not be like I want to send diagnosis request, it will directly send. It has to be in full COM mode. So all the necessary parameters are there, but that we will not cover here. I'm just giving you the brief of this diagnostics, how it happens and how it will be useful. So this is just a structure. So AUTOSAR diagnostics is advanced. I'll just tell you what exactly happens when we want to send a request or when we want to pack the data and send it back. So I'll just show you the thing. Below layer is like this one only, CANIF or Ethernet based on the protocols you are using. But let's assume that below layer is a CAN layer. So if you send some DID request, so we want to read the data. So we have some separate SID. SID means like a service identifier. So if you want to send request to read the data, it will be a 22. If you want to write the data to the controller, it will be 2A. So these all things obviously will explain in the course, but I'm just giving you brief. So if want to read the temperature of the ECU, for example, so what I will do, I will send a 22, then let's say F101. So F101 is nothing but the identifier for this ECU temperature, and 22 is a request that we are sending. So let's say it comes till this CAN layer. After CAN layer, it will go to the upper layer. So PDR, from PDR, it will let's say go at the up layer. So then this is the PDR. So DCM first check whether the request that I sent is correct or not. Means whether that DID, let's say I have said like a 22 F101. So that F101 DID is present in this list or not, for example. So then it will verify it whether it is present in the list or not. Then it will go to the next layer. DCM also has inbuilt 3 layers like a DSL, then DSG, and then DSP. So that we will dive deep into the upcoming slide. But it will first verify whether am I in the right session. Let's say to send a request, it should not happen like anyone can send the request. So we have to see whether you are in a right session or not. Session means like if I'm sending request, it should be in the default session, or it should be in the extended session, or it will be in the programming session or technician session. So these all sessions are there. Sessions means like kind of accesses, let's say. So let's say I'm right now I'm hosting this. Okay, so I have access to add people, but you don't have access to add people into the meeting. So it's like that. Based on the user, based on the things, we have different accesses. So based on that only, we can see whether we are in that sessions or not. So let's say we are in technician session, and technician session wants to modify the content of NvM parameter. So anyone can tell like whether it is allowed by technician or not. Anyone can unmute. If technician can he change the parameters of diagnose this one some NvM parameters or some memory parameters? Anyone can unmute and tell. No, correct. So that is the action. That is like a session actually. So if we are taking this car and going to the technician session, then he has a right to access only some technician related things only, like basic checks like what are the current of the battery, voltage of the battery, or some basic parameters only he has access. So similarly, it should not happen like technician want to read which modify the NVM parameter. We should not allow that. So that's why in the DCM only we have a DSL, diagnostic session layer. It will check whether you are in a right session or not. If you are in not right session, it will directly ignore the request and send a NRC. Similarly, if you are in you are developing the code, you are developing the project, then you are in always extended session or maybe programming session. So you can send whatever request you want to send, and it will be allowed. So after that, it will check whether after the DID check whether the DID is available or not. Then it will go to the next session. Then it will check like whether you want to trigger some event, or either he want to go through any of the software component, let's say software C component or software component of general diagnostics or lab, whatever it may be. Then based on the request, because if we are DID F101 belongs to engine temperature, then that port is already connected to engine parameters. So it will automatically route to the that particular component. So let's say SWC actuator, or maybe we have some data, okay, like engine control related data. Then it will go to that particular port, and it will read the data whatever available. So let's say engine temperature is 37 degrees Celsius, but it will not show directly 37 degrees Celsius. So to check the engine temperature, what this software component will do, it will first read the ADC value. So what is the ADC value? Let's say ADC value is 1.1 volt. Then it will check the resolution of it. What is the ADC resolution, whether it is a 12 bit or 10 bit. Based on that, it will do the calculation. Then it will, at the end, it will pack the data. and after that then same it will it will send this data back to the application software component, then RT. From RT it will again go to the DCM, and then from DCM it will go to PDR router, and then from the below layer. It's like that. And then on CANoe we see. So you see these all things are there. It is happen in millisecond or even microsecond. But this is a flow, like how this request sent and how data is packed. So sometimes what happen, like this DCM is also responsible for setting some event. So at that time it will directly communicate with the DEM, and DEM will do the necessary things, like whether you want to change the issue state, whether you have to disable some functionality, whether you want to log the event into the NvM, like that way. So these all things are there. So this is all about how it will flows. So we'll just check the interaction with other models. So DCM communicates with what all models. It's actually a screen. I don't know it is visible, but I'll share this presentation to you. So actually here in this things it will show like in which models it is communicating with, like IO hardware abstraction layer, DEM, then BSWM, KEM. Let's say if we want to have a secure diagnostics, like we have integrated some cyber security related stuff, then it will communicate with the KEM, then CSM, then it will obviously it has to communicate with the PDR, then COMM for management of the communication. So it's like that. Then it also communicate with our NvM, because let's say some event occurred and that event you want to store into NvM, then it has to communicate with the NvM also. Then we have routine services, data services. Data services means like it is like a DID, like read the data, and RID means like a routine services. So generally if you want to read a data or write a data, we go for the DID, so like a 22 service or 2E services. But if you want to perform some action, like let's say you want to do the start the CPU load measurement, and after starting the CPU load measurement, after 10 seconds you want to read what is the CPU load. So these are like some actions, because it is not a kind of data. So if you want to perform some actions into the into our controller, then we go for the RID. RID means like a routine services. So let's say 31 is a SID, then we can have a RID number. RID number can be anything like which is there in our Candela file. Based on that, we can send a request, and it can controller can perform certain operations actually. So this is a like a image. It will show like it is communicating with what all models. Then we have some possible interactions between the sub models in the DCM. So as I mentioned, like we have DCM, then inside DCM also we have three layers actually, like a DSL, then we have a DSD, and then DSP. DSL is like a link layer, then a DSD means a dispatcher, and DSP is like a processor. So I'll tell you a brief on each thing. Okay. So things are like whenever we got a request from outside world, it will go through the communication manager, and in the DSL it will check whether it is in the allowed session or not. If it is allowed session, then it will go to the next layer. Then DSD it will check whether it is a what we can say it is a ISID or RID. Then a relevant service dispatch, it will dispatch to that service, like 11 SID is there, like to reset the controller 1101 or 1103. Then we have some DTC controller 0x28, or maybe SID like 22 or 2E for read or write. So these all it will check, and it will call the relevant functions or files actually. And then DSP is responsible for read the data, then write the data, then it will also verify the data length. So let's say I'm requesting 2 bytes of data, but in response we are getting 12 bytes of data. Then it will show that length is not correct. All those NRCs or negative response code DSP will take care. Then DSL also check whether you are into the current session or not. You are in not that session. Let's say you are accessing any DID that belongs to extended session, that it will show you are not in the right session. It will give that NRC. We have NRC table, so you can Google it, you will get idea for all the NRCs. So like first it will communicate with the DSL, DSL will communicate with the DSD, then DSD will communicate with the DSP, and the DSP will communicate with either application component or NvM, whatever, like, because if you want to read the data, it can read from any of the application, or sometimes what happen, you want to check what is the kilometer driven by the car. Let's say you see, whenever you turn on the car, you can see that some odometer value, it shows how much kilometer that car has traveled. So that data is always stored in the NVM. So if you want to read the same data into the CANoe or maybe your diagnostic tools, then what will happen, we will send request, then that request goes to DSL. From DSL it will goes to DSD. From DSD it will go to DSP. From DSP it will go to external models like NvM or some crypto related models, and then it will read the data. Then again from DSP to DSD, DSD to DSL, and DSL to then COM, then PDR, all those things. You see here it is DCM copy RS data, DCM copy TS data. So all packing of the data will be done in the application itself, and then it will again sent back to the below layers. But one thing you have to keep in mind, that always sent and received PDU are same only. Like it is not like for one request it is different PDU, for another request different PDU. So for sent we have only one PDU, for receive we have only one PDU. So and that PDU can support TP, means transfer protocol, as well as normal protocol also. Like if you have a less than 8 byte, it will be a normal CAN or maybe Ethernet or FlexRay. But if you have more than 8 bytes of data in the data length itself, then it will directly route automatically via TP. So this is just a flow that I want to show you, like how flow will be. Like already I mentioned, but this is the sequence diagram. This sequence diagram is nothing but it will show which APIs are called and how the flow will be. So here it is starting from the PDR itself, but below PDR we have already mentioned, we have layers, like either it could be CANif or Ethernet if or FlexRay if, and below that we will be having CAN driver or Ethernet driver or Flex driver, and below that our actual microcontroller, and below that our physical wires. I request you to unmute. Okay, then so we'll see once we get the request. So this request, consider that this request we are getting from our CANoe, and then CANoe to wire, then wire to our driver layer models, and then at the end it will come to PDR. Then from PDR it will go to DSL. As I mentioned, DSL is the first layer of the uh, diagnostics. So this screenshot, this PPT anyway I am sharing. Okay, so if it is not visible, it's okay. If it is visible, then it's good only. Is it visible? Are you able to see this DSL names and all? uh, Anyone can unmute and response. Okay, even if it's not visible, I'll just naming the same, like PDR, then DSL. The request will be sent from PDR to DSL, DSL to again DSD, DSD to DSP, and then from DSP to the user. Okay, DEM user. Like if you are considering the some DEM related operations has to be done. Let's say we want to read the DTCs, or we want to check the status of the DTC. So we have some other services for checking the DTCs via diagnostics. Let's say like 19 service. Then we have a 1904, 1906, 1904 for reading the snapshot of data. Then 1906 for reading the extended snapshot data. So like that way. So whenever while sending request, if you are sending request related to diagnostics event, then only it will go to this DEM user. And if you are just reading the data or writing the data, uh, or maybe you want to perform some actions, then only it will go to the DSP. So from DSP it will route to either a relevant app software component or maybe NvM, it based on the what kind of request we have. And all the connections are already done in the RT. So it's like that. So request sent, then read data. From read data it will pack the data, then it will again go to the below layer, and from the response side then again it will pack the response and go to the below layer like a CANIP, Ethernet or FlexRip, and then as I mentioned earlier. So this is just a sequence diagram to show how what will be the exact sequence when sender sends a request, and which all APIs get involved. So if you see here APIs also. So generally when interviewer asks you question, we generally mention like that only, like yeah, it will go to PDR, DSP, DSD, DS. So no, but interviewer will not accept that. You want to mention this API information also, because this API will be common. Okay, so you can tell them like data indication functionality, then it will go to the read data, from read data to based on what it will go to DEM, if DEM related functionality are there or not. It's like that. So how you answer, based on that only someone can understand whether you are really worked or not. So just a glimpse. Okay, so this all I have mentioned. Okay, these are the basic things only, like what I want to go through, because if you want to go dive deep, then DSL itself take 2 days. Okay, DSD itself take 2 days to understand, like minimum 2 hours we have to invest on each layer. So whatever I'm thinking, it's not, I'm just giving you the overview. Okay, but I just have one question. Okay, everyone knows about the event, diagnostics event. So we have a snapshot data also. Anyone knows like what is the snapshot data? Anyone who are already having some experience, or maybe trying for having experience into that, sir? Anyone has idea on snapshot data? Yeah, freeze frame. Correct, correct. But what do you think, when that data got stored into NVM, in which way, at what time? That same time, or when? But is it stored in the variable, or it is stored in the NVM? Stored in NVM, correct? Yeah, but the thing is that generally you see in the runtime we have so many events occurred and it goes, then but it will not store in the NVM directly. Okay, so just this small correction, because everyone asks the questions now interviewer, it will ask like that only, like when store, and we always reply like this only: when diagnostics event occur, it will store the data into NVM. But this answer is actually partially correct and partially incorrect. So we have to say like it's based on the configuration, like when whether that snapshot data we have set to be immediate, or during NVM shutdown, or maybe the shutdown. So we have two cases actually here. Okay, so generally what happen, events can occur multiple times. So when we write the data into the NVM multiple times, then our NVM has a less cycle of writing. Okay, so we cannot write, let's say, more than 1 lakh times. So if you write the events continuously in the runtime, then that memory write feature will not work throughout the life of the car. So it is always considered that we will store the data of the snapshot immediately into the variable, that is RAM variable, not into the NVM. But during shutdown, whenever we turn off the car means we do the KL15 off, let's say, just turn up. It turn up means car is on only, but for you it is off. Like just background activities are stored. So during turn off, we have one time, like 1 or 2 second shutdown time. So during that only the all the diagnostics data will stored into the NVM. Yes. In the sleep, before going to the sleep mode, it has to store data into the NVM. You see, like let's say in the 10 100 events can occur in the runtime, so we should not write into the NVM. It will be write into the RAM variable, but it will write into the NVM only during the shutdown, or maybe when you do the ignition off, like that way. So we have only like a 2 second or 1 second shutdown period. During that, NVM has a capability to store all the relevant data, all the environmental data. And also another thing will be like, let's say event occurred now, it doesn't mean it will be false always. It can be it can be like a event occurred now that got displaced also, or maybe that event is for just temporary reason. So we should not store that kind of NVM data also. So it is generally recommended that we used to store NVM data during shutdown only, so that a life of our controller will increase, and uh, the NVM write cycle also will not completed early. So as you know, like every car has a lifespan of 10 years or 15 years. So it is calculated like that. So we generally store during the shutdown only. So this mostly frequently asked questions actually, because everyone ask and everyone gives the same answer. Even when I started my career first, I also given the same answer, because it is expected that it is stored immediately. It is stored immediately is correct, but it is stored immediately into the dedicated RAM mirror of the NVM, and during shutdown only it will store. So this is just one catchy question I want to ask. So I'll just go through this course details. Okay, I'll just show you like whether it's yeah. Mm-hmm. So actually it is depend, like because we have some limits also, we have thresholds also. So as soon as we set a event, it should not be like we have to store the snapshot directly, because we have two cases, like one will be the pre-failed, another will be the failed. So to mature the event, or to when we say the event is matured or settled, when that it will go from pre-failed to the failed. So we have one debounce mechanism for that. Like let's say the debounce mechanism will be either timer based, or the debounce mechanism will be counter based. Let's say we have a counter based, then and if we set that value as a 2 or 5 or 10, then that particular event has to occur at least 2 times or 5 times or 10 times in that same operation cycle. Then only we will consider that this event got matured, and it will the state of the event will be converted from pre-failed to failed, and then at that instance only all the snapshot data get recorded for that particular instance. And if that event occurred again, then another snapshot will be stored, because every event has a minimum 3 snapshots. So it's based on the occurrence counter. So another case will be like, let's say we have a delay, then delay base, let's say we have set delay as a 25 millisecond, and it will check whether the event is occurred now, and after 25 milliseconds also it is in the active state only, then we will store that the snapshot data. So it is work like that. Hello, am I okay? Okay, so another point will be like aging also, aging concept, like whenever occurred, then we have some aging concepts also. So like last, let's say 2 operation cycle or 10 operation cycle, let's say that event is not active, then we can remove that particular event from the memory, so that our memory will be free and it can accommodate the other things. So another one tricky question I want to ask you all, like let's say we have only 8 NVM blocks configured, and during init time only we got 10 events. So what will happen in that case to remaining 2 events? Any? It's related to diagnostics event. Let's say we have 8 NVM blocks only, means we can store only 8 events, okay, during any time. But during any time only, due to some issue, at the time 10 events occurred. So what do you think, what will happen to the remaining 2 event? This is just one question. It's being asked mostly in the interviews. Anyone has any idea? Priorities are same. Priorities are same. All are primary memories. At a time, I mean, yeah, we have called a main function now only, and at that instance only we have 10 faults. So that answer to this only, like based on the not priority, but based on the sequence It will store 8 only, and remaining 2 will be ignored directly, because them don't have any space of the variable to store, and all are immediate events. So immediate events means like it doesn't have any demounts. So whenever occur, it's occur. Let's say airbag, we don't have this counters, like a one time accident happen, two time accident happen, then only airbag should open. It should not be like that, right? So like airbag, it's immediate now. Similarly, some events are immediate base, so as and when occur, it will directly store the snapshot data. So it's like that only. Also the answer varies based on the occurrence count also, but mostly it will disappear the two events, and we should not have a log or any trace of those two events, and no one awares also like what will happen. So it's better to have a more NvM blocks to store the DTC. We should address the behavior, like how many faults will occur at the init time. So these are all the corner cases we have to think at the beginning only, so that we can have a relevant configuration. So this issue we have came across in our previous projects, where events are logging but we are not able to see the status. So this is just one scenario. So these kind of all the things I will be covering in my sessions, okay? And obviously you mhm, mhm. Yes, yeah, FIFO. Like, though you see, there is nothing like parallelism, okay? You see everything, you see here, it seems like it is working parallelly, but it is in the background, it is a sequential only. So it should not, like, let's say I'm calling pdr function, dsl function, dem function. It will be called at a rate of 5 millisecond, but it is speed is very high. You see, buffer is like buffer only now. At a same instance also, you feel there will be sequence only na at the end. It's not like we will write 10 events into the 0th index of array. Let's say you want to write 10 elements or 10 variables to the array at the same time, but it's not like, it will at least accommodate, at least some will be sit in the first index, some will sit in the second index, third index, fourth index. So it's like there will be always one index, where even if you occurred at the same instance, it will be having some index only, because before after occurring the events, we will be having some callbacks. So it's like that only. So I'll just go through it, the things, okay? um, so this is my plan actually, 10 students, but we can expand also, like based on the demand. If we miss, batches will be 10. It's not like we will make it 10 to 20 in the same batch, because we'll be having one-to-one sessions, we'll be having some doubt sessions also. So this 20 hours of training are thought of, but it might increase based on your request, or maybe some points are not clear. And each and every topic I'll be covering, like so that if someone asks you question, he doesn't feel that you will be having knowledge or not. So because I took more than 1,000 interviews, okay, in my career, okay, so I used to have I have took many interviews, and my selection ratio is like out of 10, I used to select one or two only. So that type of questions I usually ask, and I know like what questions to be asked, so that we'll get an idea that person is worth or not. So this is the 20 hours, but it can be increased. We'll be having some separate one-to-one sessions also, like doubt solving sessions. So we have limited to 3 hours, but if we face some issues, we can increase that also. So my main intention is not like I want to finish it in the early, but I want to make it clear. Like so after this course, you will be self-sufficient to do the things. Though you have tool access or not, you are in a position to do the things. So, frankly speaking, telling about me, I haven't done any course, nothing. I have learned myself. I have gone through the specification document of the AUTOSAR, and based on that, I jotted down the points and everything I have created. Even I have my own notes also, like handwritten notes. So obviously, that notes also I'll share. I have frequently asked questions, that also I'll share by end of the course. So at least by completing, you will get to know you are self-sufficient, and you are in a position to crack any of the interviews. Like a 4 to 5 years, or maybe 7 to 8 years experience guys also can crack the interviews, okay? So key modules that I'll be covering. So diagnostics is not like a DCM only, it has to communicate with all modules. So I'll be covering all the modules relevant to it. So it's not like diagnostics, because diagnostics, if someone asks you question, it will directly route to the NvM only. Anyone will ask that only. Let's say you want to send a request, and how you will read the data from the NvM, or how you will read the value of odometer. So how component communication will happen? I'll write the APIs. I'll tell you the APIs to be used and all those information, because no one, because tools might be different. Someone will use ATAS, someone will use C4K, someone will use EBIT resource, or someone will use DaVinci configurator. But at the end, coding will be same, AUTOSAR will be same, everything will be same. So I'll not more focusing on the configuration, because configuration is a simple thing. I'll more focusing on the functionality and working of it, like how it will work and how it will react. So everything will be like based on the things only. Everyone looking for APIs, not on the configuration. The configuration can be done by 1 year or 2 year person also. Or maybe I'll just give you the, let's say, DaVinci configurator now, you can do configuration today also. But what is the analogy behind doing the configuring the parameter? What is the value? If we set 1, what will happen? If we set 2, what will happen? What parameter has to be enabled? So each and all parameter are present in the software specification document of the AUTOSAR. So that I have already gone through it, and I have prepared some list. So what that all I'll cover in this. So it's like a what I'll cover is like a real time scenarios. Okay, it's not like whatever there in the presentation and all. I'll try to cover real time scenario, and these are some additional things I'll be giving free of cost after this. Like whatever things we are training you, or whatever things, all will be recording, so that we will give directly drive link, so you can access lifetime. Then some notes, as I mentioned, handwritten notes I have prepared for my own interviews during the times when I'm struggling to get job into AUTOSAR. Earlier I was into the embedded C only, then I have moved to the AUTOSAR, and AUTOSAR is a future, frankly speaking. Whatever things happen, but AUTOSAR will remain future. There might be chance that the other industries also may follow, not AUTOSAR but kind of AUTOSAR structure, because AUTOSAR is independent on the hardware. Let's say right now we are working on the ST microcontroller. Future you want to convert to the microchip, or maybe Infineon or Renesas, you can directly migrate without changing your application. Then we have some one-to-one doubt solving sessions. I'm planning 4 to 5 sessions based on the needs. It can increase also. Then I'll be providing 2 mock interviews additional, that is 1 hour for individual persons. And the real-time scenarios I'll cover, and that recording, mock interview recording also will provide to the individual. It will be all to personal, like we will not share yours interview to other. Okay. Then we have some diagnostic checklist, some interview guideline, some sample ARXML. Obviously, these ARXML not from the vector, but some ARXML we can look like we have some diagnostics things. We have some open source material that only will provide, and some CAPL scripts, that we have some capacity. Like if you want to send 10 DIDs or 100 DIDs, why to send it manually one by one? We can send it with the CAPL script. So some CAPL scripts also I'll try to cover in this. So that's all what I mean to say. So anyone has any doubt? Hello? Yes, yes. Yeah, I'll try to show configuration. You see, like DaVinci tools are costly, and we don't have access to that. And also, if you go to the any of the vector website, okay, it is clearly written that we if means we cannot what we can say, give the training on their tools. Okay, if something happened, like if it is identified by the vector, then they will sue us, means not me, and you also, like the one who is taking the training and the one who giving the training. So you see throughout the globe, like where someone is teaching, they will not show the things. Only if you are working in an organization, you can show to your colleague like this is a configuration. But if you want to go for the vector stuff or vector tools, we have to opt the training from them only officially. So here what I'll show you, like for us, Bible is AUTOSAR specification document, and we have some code flow, like all the APIs what we use as a AUTOSAR configurator or ETAS configurator or C4K tool or whatever may be EB tool, all the APIs are already specified in the AUTOSAR specification document. But I will show you, like, let's say what all APIs get involved. So let's say from the can read, then can from above layer will be like can if RX indication, then we have PDR RX indication, then COM RX indication, then COM read, then signal group read. What all APIs got involved, what will happen, what structure packing will happen, each and every thing what will mostly question interviewers will ask, all things I will cover there. Hmm. Hmm. But as a tools, like we miss, I also don't have that tool. Okay, so this is my personal laptop, so we don't have any tools, and no one will have. If someone is guaranteeing you that he will provide you the tool access and all, then it's like what you can say, your luck. And if something identified, then your career and their career also will go. So only one way to learn the AUTOSAR configurator is to join the organization as a AUTOSAR engineer or AUTOSAR developer. And how to join as a AUTOSAR engineer or developer, that I will make you self-sufficient so that you can join any organization as a AUTOSAR engineer or developer. So I'll make you that level of capable. Okay, because I don't want to give the false commitment. But you see, 20 hours I'll be investing, and another 7 hours additionally. So that is what I'm investing. And that's the thing. Because what I mean to say, this start this course is like many of my friends are asking for this one. I already have one gone through one batch, so this is the second batch I'm starting. Okay, so in the second batch, I'll be targeting, first batch I targeted with my friends only, and then they suggested to move ahead and will post on the LinkedIn. I got a good response from you. Thank you all for joining this demo session. And this demo session is just to know, like, it should not happen. You should not blindly register. Okay, so I just want to showcase my skill set. So it should not happen like you will feel regretful to have a joining of the course and all. So just this is the demo session that I have provided the brief information. So course fee is this one. Mm-hmm. Yeah. Yes. Yeah, yeah. Well, I'll give you the resume. I'll also try to add, tell you the bullet points to be added to showcase that you are AUTOSAR developer. And because you see, AUTOSAR is the thing. It's a future, actually. Frankly speaking, I don't know what rumors are there in the market. People are saying automotive will go down, but it will not happen, because without car you will not travel, right? If someone have a car, let's say in a Tata car, they have a targets to maybe to the next car, like maybe MG or some other. So cars will be there, cars will be future. So there will not be any down trend for that, sir. So this is the future, frankly speaking. Yeah. So this about the fee, actually. This fee is like a 35,000 that I'm targeting for one individual, providing we have a 20 hours of study, 20 hours of study, and 5 hours additionally for one-to-one doubt session, and 2 hours for the mock interviews. But who all joins here, I'm giving you a 2,000 discount. And who all are, I'm not forcing anyone, because this is a free session. If you want to migrate to the AUTOSAR, if provided you have a embedded C skill set, this is the prerequisite. Obviously everyone has a 2 years 3 years experience minimum. So you want to migrate to the AUTOSAR, and then this is the right opportunity. I'll make you self-sufficient to be AUTOSAR developer and crack an interview, actually, of any of the organization. Okay. And if you anyone is really interested, he can fill up this information. This I'll provide you in the chat, and then we'll soon meet. Okay. So thank you all for support. I will provide this PPT also to you over the email. And those who are not having registered, they can send their emails on this chat only, so that I can send this particular link to them, and also I'll share a PPT also. So those who directly joined, they can send. Okay. Thank you all. Yes. Yes. We can maximum have two installment actually, because you see hours are more, and it's not happen like someone pays up to 50% now and later he said no, I have learned so much, now I don't want to continue. So this fee is that way we have considered. But yes, in special circumstance we can provide a two installment based on the financials. Okay, individual financials. Yeah, miss. I'm trying to cover in month only, or maybe less. Saturday, Sunday, I'll try to target at least 3 hours, because weekdays everyone is working. So weekdays maybe alternate alternate day 1 hour, or maybe 1 hour a day based on the things. Okay, because I also have some company works and release activities. But mostly we'll try to cover Saturday, Sunday, 3 hours or 4 hours, and all things are recorded. Okay, so we'll get a recording also. If you miss some point, we can have a doubt solving sessions additionally, and two mock interviews per person. Okay, I'll just share these details. Make sure that you are, if you are directly joined, send email ID here only. I will share this link, and please register if you are interested. So there is no force, like as I have limited my batch to 10 persons only. If more people join, then I might have to create one more batch, because intention is this only, to make you comfortable in AUTOSAR. I'll also share the PPT here. I have shared this form. Everyone got? Okay. I'll share over a mail also. Okay. Thank you very much. Bye.